Hey everyone, this is Shauna, and I'm coming to you this week with your check-in for geometry, giving you a little overview of the sections that you're going to be covering and maybe some hints to help you with your homework along the way. So without going into too much detail, let me slide into my share at this time. The first section that you're going to be looking at this week kind of picks up where you were last week. Last week you were talking about polygons and triangles and different kinds of triangles. This lesson focuses specifically on isosceles triangles. And isosceles triangles, as you might remember, are triangles that have at least two sides the same. If you have three sides the same, it's equilateral, and technically those are isosceles, but we're focusing on isosceles triangles with two sides of equal length. The sides that are equal length, we call them legs, and the other side is the base. The angles along the base that are opposite either of the legs are called base angles, and the point at the top is the vertex angle. So the base angles of an isosceles triangle are equal in measure. So you have a couple of theorems here to help you with that. One basically says that if two angles are congruent, then the sides opposite those angles are congruent, and the other one says that if the sides are congruent, then the angles opposite them are congruent as well. So we have those two theorems in here. And a couple of examples. Something else that I wanted to point out. We talked about the idea of bisecting before, and we've talked about this. To bisect means to cut in half, to cut into equal halves, even if it doesn't look like it. And you can bisect a line. So we had the segment bisector, the perpendicular bisector, and we have an angle bisector, and we have theorems about the angle bisector. Each angle in a triangle has a unique angle bisector. So there's one bisector that goes through vertex A. There's one bisector that goes through vertex B and one that goes through C, as you see here. And there's properties for those different angles. And then we have some other terms that you need to be familiar with. We have median, okay? This is not the same median that you might have seen in other contexts. This is talking about medians go from the vertex of an angle to the midpoint of the opposite side. That's what the median is. So don't confuse that with cutting the angle in half. This is cutting the side exactly in half. Just because you cut the angle in half doesn't necessarily mean you cut the opposite side in half. So be careful with that. That's angle bisector versus median. And then we have altitudes. Now altitudes are always perpendicular to the opposite side. They don't have to go through the middle. They just have to be perpendicular to the opposite side. So make sure you understand that. And then we talk about the perpendicular bisector, and there's some definitions and corollaries for that on the rest of the slides in this lesson. And then at the very end, it has a nice summary of some of the properties of triangles. So we have scalene triangles, isosceles triangles, equilateral, acute, right, and obtuse. And it gives you some of the properties of the sides and some of the properties of the angles. So be sure you study up on that. Now let's take a look at, I'm going to stop sharing this screen here, and I'm going to go to my other screen share for another piece of your lesson. Whoops. Another piece of your lesson this week is the inequalities that define triangles. So remember, we have equations with equal signs, and we have inequalities that have other symbols, and we have some important inequalities that describe triangles. So let's take a look at those slides here. And one of the theorems that you're going to be looking at is if one side of a triangle is longer than a second side, then the measure of the angle opposite the longer side is greater than the measure of the angle opposite the shorter side. Now, what is this saying? This is basically saying that if I have a triangle, let me come down here. If I have a triangle here, A is 80 degrees, B is 40 degrees, and we know by extension that C must be 40 degrees because the angles in a triangle have to add up to 180. But the point that she's making here is that 80 is obviously bigger than 40 degrees. So the side opposite vertex A, which is BC, because it's opposite the larger angle, has to be longer. BC has to be longer than the side opposite angle B, because angle B is only 40 degrees. And this makes sense. If you make an angle large, then the side opposite will have to be longer in order to connect the points of the triangle. Try it yourself and you'll see what this means. But basically what it says is that if you have 3 angles in a triangle, the shortest, this was talking about 2 angles, but we also have something for 3 angles coming later. Basically, the smallest angle is going to have the shortest side opposite it. The largest angle is going to have the longest side opposite it, and the one that's between the two will have a side opposite it that has a length between the longest and the shortest, if they're all different lengths. Now let's take a look at the second theorem here. If the measure of one angle of a triangle is greater than the measure of a second angle, then the side opposite the larger angle is longer than the side opposite the smaller. And this is pretty much another version of what we just got done saying, which leads us to the corollary of that if you draw a perpendicular line segment to a point, it's the shortest segment that can be drawn from a point to the line. That's because of the fact that it makes 2 triangles. This one is not immediately obvious, so study it. What it's saying is not immediately obvious, but it's intuitively clear. It's just an extension of what we saw in the first. There's a couple of corollaries here. There's an important inequality here that tells you if you have a triangle or not. So sometimes you can look at lengths, or you can look at pieces of a triangle, and you wonder, would they make a triangle? Would they be long enough to do it? And the way you figure that out is you add up any two of them, and it has to be greater, not equal to, but the sum of the two that you choose to add has to be greater than the third one. And yes, you have to test all three. All three of these have to work. If one of them fails, then you do not have a triangle. And there's a couple of examples of that to finish out this lesson. We have one more lesson in this week's module. So let me stop sharing this and let me open up the third lesson, which is section 4.1. We're going to temporarily get away a little bit from triangles, and we're going to start with some properties of parallelograms. And if you remember last week, you talked a little bit about quadrilaterals, and I told you then that it might not be immediately obvious to you because quadrilaterals are four. And I told you that usually when people think of four-sided figures, they think of squares or rectangles, but there are other four-sided figures, quadrilaterals, and we're going to learn about some of them here in the whole chapter. In chapter 4, the first one is a parallelogram. You may or may not have heard of that before, but it is just what it sounds like. Parallel, you know what parallel means? Gram is a shape. So this is a parallel shape. And so a parallelogram is a four-sided figure where the opposite sides are parallel to each other. So they don't kind of careen and get closer to each other. They stay the same distance apart all the time, and you have a parallelogram. And this whole lesson is about the properties of a parallelogram. And it turns out that on a parallelogram, both sets of opposite sides are parallel, and they're also congruent. So in this picture, AB is congruent to CD. Remember, congruent means the same shape and size, in this case, the same length. And side BC and side AD are congruent. The markings here indicate congruence. One hash mark is congruent to one hash mark. Two hash marks are congruent to two hash marks. So opposite sides are parallel, they're congruent. Opposite angles are congruent. Now, consecutive angles are a little bit tougher. Consecutive angles, if you look at this middle picture, consecutive angles are angles that continue along the same side. So A, B, B, C, C, D, and DA are consecutive angles. A and C are not consecutive, they're opposite angles, okay? So opposite angles are congruent, and consecutive angles are supplementary. They add up to 180 degrees, and it turns out also that diagonals bisect each other. So diagonals meet in the middle of each other and create two sets of congruent segments. Okay, so we have examples of that for you to look at. And there's a couple of theorems about that. Let me just point out this issue on slide 9. We talked about altitudes for triangles. The altitude of a parallelogram is drawn from one vertex so that it is perpendicular to the non-adjacent side. Obviously, because if it were drawn to the adjacent side, then it would be somewhere in the middle. We want it to be perpendicular to the ground. So sometimes, as in the first example right here, your parallelogram is in black, and you have to extend the side to make a perpendicular. That's perfectly okay to do as long as the extension you make is perfectly straight and your altitude is perpendicular to that. So that is about all I have for this little lesson overview. Again, it's not meant to replace your lecture. It's not meant to replace your study time. It's meant to augment it and give you a few hints and a little bit of help, either before you go into the lesson or once you've been looking at it, to give you a couple of hints about things that are subtle that you might have missed. I hope these videos are helpful to you. I hope you're getting something out of it. Stay safe, everyone. And Lord willing, I'll talk to you very soon. Take care. Bye for now.